Pascal Math Contest 2022, Grade 9. Number 1. The expression 20 plus 22 over 2 is equal to 20 plus 22 over 2. That's the 42 over 2, which is 21. So the answer of the number 1 is D. Number 2, the graph to the right shows the amount of money that each of 4 students donated to a school fundraiser. The total amount of money that they donated was, so Hofi donated the $2. Mike donated $6. Pierre donated $2 and Ritika donated $8. So the total, the donation, that's the $18. So the answer of number 2 is B. Number 3, the value of the 1 over 2 plus 2 over 4 plus the 4 over 8 plus 8 over 16 is 2 over 4, cancel 2, that's the 1 over 2. 4 over 8, cancel 4, that's 1 over 2. 8 over 16, cancel 8, that's the 1 over 2. Now repeated adding is multiplying. So 4 1 over 2 add together, that's the 4 times 1 over 2. Therefore, the answer is 2. That's the E. Number 4, which of the following number is closest to negative 3.4? Negative 3.4 is between negative 4 and negative 3. Halfway is the negative 3.5. So 3.4 is the right of halfway. So the negative 3 closest to the negative 3.4. Therefore, the answer is B. Number 5, points P, Q, R, and S are on a number line as shown. The ratio of lengths PQ to QS is, the ratio is the PR to QS. PR is the distance, is the 10 minus 3, and 2 QS is from here to here. That's the 17 minus 5. So that's the 7 to 12. So the answer is A. Number 6. Robin has 4 tasks to do and Sasha has 14 tasks to do. In order for Robin and Sasha to do the same number of tasks, how many of Sasha's tasks should Robin do? Robin and Sasha total has the 4 plus the 14. That's the 18 tasks to do. If each does the same number of tasks, each must do divided by 2. That's the 9 tasks. This means the Robin need to do 9. Right now he do the 4. So he need to do the 5 more tasks. So that's the answer C. Number 7. In the diagram, the lengths of 4 of the sides of the figure are shown in terms of x, assuming that x not equal to 0. The perimeter of the figure is, for the shape like this one, the perimeter, that's the length, that's the 2x plus width 3x times 2. So that's the 10x. If we draw the rectangle like this, so top, the side equals to the bottom. This, the two tick mark one, equals another tick mark one. So that means the perimeter equals 2x plus 3x times 2. So that's the answer E. Number 8. A circular spinner is divided into 4 sections as shown. The angles at the center of the circle in the section labeled green, blue, each measures 90 degrees. An arrow is attached to the center of the spinner. The arrow is spun once. What is the probability that the arrow lands on either red or yellow? We know the total central angle in the circle is 360, and the blue is the 90. Also, the green still the 90 over 360. That's the 1/4 plus the 1/4. Cancel 90, that's the 4. Cancel 90, that's the 4. So that's the 1/2. The probability the arrow lands on the red or yellow. Probability is the 1 minus the blue and the green, so that's the 1/2. Therefore, the answer of the number 8 is D. Number 9, the line width equation y equals 2x plus b pass through the point -4 and 0. The value of the b is y equal to 2x plus the b, because the equation passes through -4 and 0. So this coordinate satisfies the equation. We plug into equation. That's the 0 equals 2 times -4 plus b. First coordinate is the x. Second coordinate is the y coordinate. So 0 equal to -8 plus b, and b equals the 8. So number 9, the answer is E. Number 10, on the map shown, there are a number of routes from Mathville to Algebra Town. Each route must travel along the roads in the direction marked by the arrows. The total number of routes from Mathville to Algebra Town is, from Mathville to the top, that's just the one way. That's the here. The arrow is here. So from here is the one way. From the bottom is the one way. Now we can do the here. That's the 1 plus 1, because here is the 1. So 1 plus 1 plus 1, that's the 3. And the bottom, this point, that's the 1 plus 3, that's the 4. And the top right corner is the 1 plus 3, that's the 4. And the destination is the 4 plus 4, that's the 8. Total roots, that's the 8. Therefore, the answer is C. Number 11. In the diagram, points P, Q, R, and S are at intersections of grid lines. In the 6 by 6 grid, what is the perimeter of the parallelogram PQRS? PS3, RQ, that's 3, 2. PQ, we use Pythagorean theorem. So QS is the 4. Pythagorean triple 3, 4, 5. Here is the 5 and the 5. So the perimeter equal to 3 plus the 5 times 2. That's the 16. So the answer of 11 is C. Number 12. How many of integers from the 1 to 100 inclusive have at least one digit equal to 6? Now we list the ones digit equal to 6. That's the 6, 16, 26, 36, 46, 56, 66, 76, 86, 96. That's all. Now we list the 10th digit equals 6. So from here, the after 66, that's the 67, 68, 69, before 66, 65, 64, 63, 62, 61, 60. From 60 to 69, that's the 10 number. From the 6 to the 96, also the 10 numbers. So 2 times 10, but we have the over counting. So we count 66 2 times, so minus 1. That's the 19. Therefore, the answer of 12 is C, 19. Number 13. Maya and Rosie are 90 meters apart. Starting at the same time, they run towards each other. Maya runs twice as fast as Rosie. How far has Maya run when they meet? So, the Maya is here. The Rosie is here. So Rosie, Maya, they runs toward each other. They will meet somewhere in the middle. So the Maya, if the runs the x, the distance, we know distance equals speed times time. If the Rosie runs the distance is the speed times time. Maya, because Maya runs twice as fast as Rosie, so the Maya runs the 2 speed. So Rosie's speed is s, Maya will be the 2s times the time. That's equal to the x. 2st equals x, so st equals the x over 2. St, that's the Rosie's distance, so Rosie runs the x over 2. Also, we know Maya and Rosie are 90 meters apart, so That means the x plus x over 2, that's the 90. That means 2, 3 over 2, x equals the 90. X equals the 90 times 2 over 3. Cancel 3, that's the 30. 2 times 30, 60. So the answer of 13 is 60. Number 14. Drew is older than the Bow. Bow is older than Elysium. Elysium is younger than Andy. Andy is younger than Bow. Bow is younger than Cao. Who is third oldest? Let's write down their relation. So first one is the D, older than Bow. D age is greater than Bow. Bow is older than Elysium. And Elysium is younger than Andy. So Elysium is the younger than Andy. And Andy is younger than Bow. Bow is younger than Cao. So that's the younger than C. Who is the third, the oldest? So look at these two. So I copy the D greater than B greater than E. So now the first two must C and D. We don't know who's first, but it doesn't matter. They ask who is the third oldest. Definitely third oldest is the B. So the number 14, the answer is B. Number 15. How many of the integers 19, 21, 23, 25, 27 can be expressed as the sum of two prime numbers? Now the number is the 19, 21, 23, 25, 27. All these numbers are odd number. Odd number, right, has the two prime number. So we know odd plus odd. That's the even. So they must be the odd plus even. Give us odd number. So this, the 5 odd number, must write as 2. On the even number, only 2 is the prime, all the other not prime. So we write as the 2 plus the prime number. So that's this one. So we do is how we easy to calculate this. We just use the odd minus 2. If it is the prime number, then that's our answer. So we will use this way to calculate very easy. 19 minus 2, that's the 17. This is the prime. So 21 minus 2, that's the 19 prime. 23 minus 2, that's the 21, not prime. 25 minus 2, that's the 23, that's prime. 27 minus 2, that's 25. Therefore, the answer of 15, that's the A. Number 16. Alvin, Bingyi, and Chaska play a two-player game. that never ends in a tie. In the recent tournament between the three players, a total of 60 games were played, and each pair of players played the same number of games. When Alvin and Bingy played, Alvin won 20% of the games. When Bingy and Chaska played, Bingy won 60% of the games. When Chaska and Alvin played, Chaska won 40% of the games. Total is the 60 games, and each player played the same number of the games. That means the A play with the B, and B play with the C, and C play with the A. Each pair, they got the same games. Use the 60 divided by 2. So each pair, that's the 20 games. And A play with the B, the A win the 20% of the games. 20% of the games, they play 20, so times 20. Percentage cancel the 20, that's the 4, and the B will be the 20 minus 4, that's the 16. B to C, the B wins the 60%, so 60% times total game 20. Percentage cancel 20, that's the 12. C win 8 games. C to 8 games, C win the 40% of the 20. Percentage cancel 20, that's the 8. A is the 12. So the number of the games B win, that's the 16 here, and another here. So 16 plus 12, that's the 28. Therefore, the answer is C. Number 17, the integers a, b, and c satisfy the equation a plus 5 equals b, and 5 plus b equals c, and b plus c equals a. The value of b is, now we write down the a plus 5 equals b, and 5 plus b equal to c, and b plus c equal to a. So if we add the first two equations together, that will be the a plus b plus 10 equal to b plus c. B plus c equals a, so we write as the a plus b plus c equal to a. So cancel a. B plus 10 equal to 0. B, that's the negative 10. So the answer is C. Number 18, 5 balls numbered 1 to 5 are placed in order on a table. A sequence of steps is performed on the balls. In step 1, the rightmost ball is picked up and put in the middle of the 4 remaining balls. Then in step 2, the leftmost ball is picked up and put in the middle of the 4 remaining balls. These steps repeat. with the rightmost and leftmost balls alternate picked up and put in the middle of the 4 remaining balls. Immediately after step N, the balls are in the reverse of the original order. Which of the following is a possible value of N? Now that's the start is the 1, 2, 3, 4, 5. So step 1, step 2, and we continue do this one. Now this time we will move the 4 in the middle. That will be the 2, 5, 4, 1, 3. And then we will move the 2, that's the step 3. So step 1, step 2, step 3. Now step 4, we move the 4 in the middle. So that will be the 4, 5, 2, 1, 3. Now we move the 3 to the middle. That will be the 5, 4, 3, 2, 1. Now look at the step 5. That's the reverse of the original number. So we can conclude 5 steps, they are reverse. So we need the next 5 the step, that means to the 10, they will be the 1, 2, 3, 4, 5. And now we find the pattern. The reverse order must ending with the 5. And the same order, 1, 2, 3, 4, 5, must end in 0. That means first the reverse is the 5, second is the 15, and then 25, and then 35. All the number ending with the 5, that's the reverse one. So for the same the order must ending with the 0, that's the 10, 20, 30. Question is, which of the following is possible value of the N? N is reverse. N the reverse of the original order. So ending with the 5, that's the only answer E. If they ask the same order 1, 2, 3, 4, 5, that will be A. So the answer of the 18 is E. Number 19. Miyuki texted a 6-digit integer to Greer. 2 of the digits of the 6-digit integer were 3s. Unfortunately, the 2 3s that Miyuki texted did not appear, and Greer instead received the 4-digit integer 2022. The number of possible 6-digit integers that Miyuki could have texted is. So 6-digit number 1, 2, 3, 4, 5, 6. So with the 2 3s, so the 2 3s, where we put it, so that is the 6th position. Use the combination. 6th position, we choose the 2 to put on 3. So the combination, that means the order doesn't matter because 2 number is the same. So we put the 3, 3. So here, or this one move to here. This one reverse their position, it's the same. If the 2 number is the 5 and the 4, That means not a combination. That will be order does matter. That's the permutation. But this one, 2, 3, is the same number. So order doesn't matter. We just from sixth position choose 2 to put the 3. So that's equal to 6 times 5 over 2 factorial. 2 factorial is the 2 times 1. Cancel 2, that's the 3. So which is 15. If use the calculator, just use the 6, choose the 2. So first put the 6 and the second key, choose the NCR and then put the 2. They will give us the same, 15. Therefore, the answer of 19 is E. Number 20, a pizza is cut into 10 pieces. 2 of the pieces are each 1 over 24 of the whole pizza. 4 are each 1 over 12. 2 are each 1 over 8, and 2 are each 1 over 6. A group of n friends share the pizza by distributing all of this pizza. They do not cut any of these pieces. Each of the n friends receives in total an equal fraction of the whole pizza. The sum of the values of n with n greater or equal than 2, less or equal than 10, for which this is not possible, is 10 pieces of the pizza. The 2 is the 1 over 24. So that's the 2. And also 1 over 12, that's the 4. So 4, 1 over 12, 1 over 12, 1 over 12. And the 2, 1 over 8, 1 over 8, and 1 over 8. And then the 2 are each 1 over 6. That's the total pizza. I just draw the circle if this is the one pizza. So the 2 piece is the 1 over 6. And the n friend, they share the equal fraction. That's the n friend. The share is the 1 over n. And the largest the fraction is the 1 over 6. That means any of the n friend to share at least 1 over 6. Because we cannot cut to the 1 over 3, 2 1 over 3. Each piece cannot be cut. So that's why I need the friend share at least 1 over 6. So maximum of the n is the 6th person. Over the 6th person, not enough. So maximum is the n equals 6. N cannot equal to the 7, 8, 9, 10. Now we rewrite the fraction to the same denominator, easy for us to calculate. So the LCM is 1 over 24, is the 24. So 1 over 24, 4, 2 over 24, 1 over 12, right, as the 2 over 24, 4 pieces, 2 over 24, 2 over 24, and the 2, that's the 1 over 8, right, as the 3 over 24, 3 over 24. the 1 over 6 right 4 over 24. 4 over 24. Now because the denominator is the 24, we just add the numerator. So the numerator is the 1, 1, 2, 2, 2, 2, 3, 3, 4, 4. So if n equals 2, so 1 over 2, that's the two friends get. 1 over 2, we can easily as the 1 plus 2 times 2. For 2, we cut in half. For 2, we use the 2, 2 for one person. 2, 3, each person gets the 1, 3. And the 2, 4, each person gets the 4. So we have the 2, that's total is the 12. So each one, 12 over 24, that's the 1/2. So this equals the 12. Now if n equals the 3, and each person share the 1/3, total the 24, 1/3, that means the 8. We will figure out the numerator equals to the 8. So equal to the 8, we can use the 2, the 4, 4, that's the 8. 4 plus the 4. That's the 8, one friend. And 4 times 2, that's the 8. And then the 2 times 1, that's the 2, 1, plus 2 times 3, still the 8. So each person gets the 8 over 24, that's the 1/3. Now if n equals the 4, each person gets the 1/4. So 1/4, that means the 24 divided by 4, that's the 6. So easy way to get the 6, that's the 4 plus 2, that's the 6. Another 4 plus 2, 6. And 3 plus 3, 6. And then we have the 1 plus 1 plus 2 plus 2. Still have the 2, 2. That's the 6. So each person gets the 6 over 24. That's the 1/4. If the n equals the 5, so one person share the 1/5. 1/5 not working because the 4 plus 1, that's the 5. 4 plus 1, 5. 2 plus 3, 5. 2 plus 3, 5. Just leave us 2 plus 2, not 5. So 5n equals 5, not possible. And how about n equals 6? 1 over 6. 1 over 6, that's the 4 over 24. Each person gets the 4 part. So we first have the 1/4, 2/4, 2 plus 2, 3/4, another 2 plus 2, 4/4, and 3 plus 1, 1/4, another 3 plus 1, 1/4. So that's 6 is possible. Not possible is the n to the 5. So already look at the beginning, we find the 7, 8, 9, 10, not possible. Right now, plus the 5. Add them together. That's equal to 39. So the answer of the number 20 is 39. That's the D. Number 21. A 5 by 5 pegboard and a 10 cm by 10 cm pegboard each have holes at the intersection of invisible horizontal and vertical lines that occurs in 1 centimeter interval from each edge. Pegs are placed into the holes on the two main diagonals of both pegboards. The 5 cm by 5 cm pegboard is shown. It has 16 holes. The 8 shaded holes have pegs, and the 8 unshaded holes do not. How many empty holes does the 10 cm by 10 cm pegboard have? This is the 5 by 5 pegboard. We try to use this pegboard to find the pattern. So if the pegboard is the 1 by 1, is the 1 by 1. So in the graph will be like this. So the holes, it's the 0. So the diagonal 0, no holes, so no diagonal. We can put the pegs on the holes. That's the 1 by 1. If it is the 2 by 2, so the 2 by 2 pegboard is this. Side length is the 2. Only the 1 holes, so 1 by 1. The diagonal, we can put the diagonal will be the 1 because we draw the diagonal like this one and this one. So they are intersect at the center, just the 1 holes. We can still see that's only the 1 holes. That's the 2 by 2. Now we come to the 3 by 3. So 1, 2, 3 by 3. How many holes? For the 3 by 3, the holes is the 2 by 2. Holes is the 2 by 2. What's the diagonal will have? They put the main diagonal. So on the 2 by 2, we'll draw the diagonal. Diagonal is here. 2 by 2, the diagonal is here. That's the 4 holes. Hole is also the 2 by 2. We go to the 4 by 4. The 4 by 4, the pegboard is like this. So the 4 by 4, how many holes? Holes, that's the 3 times 3. 3 times 3, that's the 9. And how many in the diagonal? So the diagonal, that's the 3 plus 3. 3 times 2. But this is the odd number. So they have the 1 over counting in the middle. So minus 1. So on the diagonal, it's the 5, the solid holes. That means put the peg. So that's the 5. Now for the 5 by 5 right now is the 5 times 5. How many the holes? Holes is the 4 by 4. And the diagonal, that's the 4 times 2. Because the 4 is the even number, so no over counting in the middle. When the two the diagonal intersect, That's nothing there. So we can find the pattern. If the 10 by 10, then the holes will be 9 times 9. That's the 81. And how many holes on the diagonal? 9 is the odd number, so 9 times 2, 2 made diagonal, we need the minus 1. So how many the empty? We just use the 9 times 9 minus the main diagonal with the pegs. So that's the 81 minus 2 times 9, 18, minus 1, 17. So the answer is 64. The answer is 64. Number 22. What is the integer formed by the rightmost 2 digits of the integer equal to 4 to the power 127 plus 5 to the power 129 plus 7 to the power 131. So the 4 to the 127 plus 5 to the 129 plus the 7 to the 131. So they ask the rightmost 2 digits. That means the last 2 digits. So we'll find the pattern. The 4 to power 1, that's the 4. 4 square, that's the 16. 4 cube, that's the 64. 4 to power 4, that's the 256. Last 2 digit, 56. 4 to the power 5. I just write down the 2, use the 56 times the 4, that's the 24. 4 to power 6, use the 24 times 4, that's the 96. 4 to power 7, that's the 84. 4 to power 8, that's the 36. 4 to power 9, last 2 digit, that's the 44. 4 to power 10, that's the 76. 4 to power 11, that's the 04. So now we find that the every 10 number, that's the repeating. 4 to power 127, we use the 127 divided by 10, that's the 12, remainder 7. Remainder 7. So remainder 1, that's the 4 to power 1. Remainder 7, that's the 4 to power 7. Last 2 digit, that's the 84. Now we do the 5. So for the 5, only the 5 to power 1, that's the 5. And from the 5 to power 2, last 2 digit, always the 25. 5 cube, 25. So 5 to 129, last 2 digit, that's the 25. For the 7, 7 to power 1, that's the 7. 7 square, that's the 49. 7 to the power 3, that's the last two digit, that's the 43. 7 to power 4, that last two digit, that's the 0, 1. 7 to power 5, that's the 0, 7. Now we find from the 1 to 4, every 4 number is the repeating for the last two digit, and the 131 divided by 4, divisible by 4 rule, that's the last two digits. So we use the 31 divided by 4, that's the 7. Remainder 3. So that's the 131 divided by 4, remainder 3. So remainder 3, same thing, that's the 7 to power 3. That's the remainder 3. So the 7 to 131, the last two digits, that's the 43. Last two digits of this the number, they equal to 84 plus 25 plus 43. That's the 152. So last two digits, that's the 52. So the answer of 22, the last two digits, that's the 52. So the answer is 52. Number 23. In the diagram, two circles are centered at O. The smaller circle has a radius of 1, and the larger circle has a radius of 3. Point P and Q are placed on the larger circle so that the area of the two shaded regions are equal. If angle POQ equals x, what is the value of the x? Since the shaded area are equal, so we label the top part area is the A. We label the smaller circle shaded area is the B. Now the area is shaded area equal, so A equals B. I label the smaller white part is the C. Equation both sides plus the C. So A plus the C equal to B plus the C. So A plus C, that's the sector POQ area. Sector area formula, so area of the sector, that's the theta over 360 times pi r squared. Theta is the central angle. For this problem, central angle POQ, that's the x. So A plus C, that's the sector area, x over 360 times pi r squared. The larger circle has the radius 3, so times 3 squared equal to B plus C, that's the smaller circle. So smaller circle is the pi r squared. Smaller circle radius, that's the 1. So 1 squared. Equation both sides cancel 1. So, and 3 squared, that's the 9, cancel 9. That's the 1. 360 cancel 9 is the 40. X over 40 equals 1. X equals the 40. So the answer of 23, the value of the x is the 40. Number 24, a pretty number is a 7-digit positive integer with the following properties. The integer formed by the leftmost 3 digits is a perfect square. The integer formed by its rightmost 4 digits is a perfect cube. Its 10,000 digit and 1's digit are equal. Its 1,000 digit is not 0. How many pretty numbers are there? 7-digit number. That's the 1, 2, 3, 4, 5, 6, 7. Also, the first 3 digit, that's the perfect square, that's the a square. Last 4 digits, that's the b cube. 10,000 digit is the c, 1's digit, also the c. 1,000 digit cannot be 0. A square, 3 digit from the 10 square. 10 square, the 1's digit c, that's the 0. 11 square, 1's digit c is the 1. 12 square, that's the 4. 13 square, c is 9. 14 square, c is the 6. 15 square, c, 1's digit is the 5. 16 square, 1's digit is the 6. So I put the after the 14 square. Then we go to the back order to the top. 17 square, 1's digit is 9. 18 square, 1's digit, that's the 4. 19 square, 1's digit is the 1. 20 square, 1's digit 0. 21 square, 1's digit is the 1. 22 square, that's the 4. 23 square, c is 9. 24 square, c is 6. 25 square, c is the 5. 26 square, c is the 6. 27 square, 1's digit is 9. 28 square, 1's digit is the 4. 29 square, 1's digit is 1. And 30 square, 1's digit is the 0. 31 square, 1's digit is the 1. So I put before the 11 square. Now we find all the a square. 1's digit just 0, 1, 4, 9, 6, 5. Now we look at the b cube. That must be the 4-digit number. So the b cube we can do. B cube is the 4-digit number. Start from the 10 cube. That's the 1's digit is the 0. So both the 1's digit is 0. I put the 1 the row. And the 11 cube, 1's digit is the 1. 12 cube, 1's digit is the 8. So no the 1's digit 8. 13 digit, 1's digit 7. No 7. 14 cube, 1's digit is the 4. 15 cube, 1's digit is the 5, so I put on the bottom. 16 cube, ones digit is the 6. So 6 square cube, always the 6. 17 cube, that's the 3, so no 3. 18 cube, that's the 2, so no 2. 19 cube, ones digit, that's the 9. We put the 19 cube here. So 20 cube, that's the put on the top. Ones digit is the 0. 21 cube, ones digit is the 1. 22 cube over the 4 digit, that's the 5 digit. So we list all the A square is the 3 digit, and the B cube is the 4 digit numbers here. So for the C equals the 0, that's the ones digit and the 10,000 digit. A square has the 3 numbers with the ones digit is the 0. The B cube has the 2 digit, that's the 3 times 2 plus ones digit. The A square has the 1, 2, 3, 4, 5, and the B cube has the 2, 11 cube, 21 cube, 5 times 2, that's the ones digit is the 1, plus the 4 has the A square, ones digit 4 has the 4 number. The B cube, ones digit is the 4, just the 1, plus 9 has the same thing, the 4 times 1. And 6 has the 4 times 1, that's the 4. And 5 has the 2 times 1, that's the all 7 digits number satisfy are the properties. That's the 6 plus 10 plus 4 plus 4 plus 4 plus 2. That's the 30 total, equals to 30. Number 25. A hexagon prism has a height of 165 centimeters. Its 2 hexagon faces are regular hexagons with sides of length 30 centimeters. Its other 6 faces are rectangles. A fly and an ant start at the point X on the bottom face and travel to point Y on the top face. The fly flies directly along the shortest route through the prism. The ant crawls around the outside of the prism along a path of constant slope, so that it wins around the prism exactly n plus 1 over 2 times. For the positive integer n, the distance crawled by the ant is more than 20 times the distance flown by the fly. What is the smallest possible value of the n? First, we calculate the distance flown by the fly. So the distance, that's the shortest distance, that's the xy. So how we find the xy? We connect this part. So this is the right triangle. This one is the z. So xz, that's the length of the height. So that is 165. And then the zy. So what's the zy? Top is the regular hexagon. That's the regular hexagon. So hexagon has the property. That's the each this angle. So because the 60 part total around the center is the 360, each part that's the 60 degree, and also bottom also the 6 because center to the each the vertex the length is equal. So the 6 the triangle are all equilateral triangle. So side length is the 30. And then this one from the y to z. So the center, that part is the 30. This part is 30. Total zy, that's the 60. So we get the 60 here. So Pythagorean theorem, xy square equal to the xz square plus zy square. So that's the xz, that's the 165 square plus 60 square. That's the 30,825. So xy equal to square root of the 30825. It's not a perfect square. I leave it like this. Now we calculate what's the nth, the root. So the nth start from the x, but it goes around the outside of the prism at the constant slope. So it goes always like the same slope. And then come to here, still here, still here. N's go the n plus 1 over 2 times. What is the 1 times? So if I open this part, we write open this one, it will be the all like the, if this is the first the 6, so 1 2 3 4 5 6, the n's from the x they go the constant slope. Now they back to the x again, they still another 6, they still go, it still go like this and continue on the many one. So it will go directly to the y. So the height of the nth the roots, the height total is the 165. This is the right triangle. And the length, what's the length? When the ants cross the prism 1 times surface, that's the 6 times 30. Because side length is the 30, so they have the 6 lateral surface. So 6 times 30, 6 times 30. How many 6 times 30? n plus 1 over 2 times 6 times 30. That's the base, that's the 180 times n plus 1 over 2. That's the 180 n plus 90. That's the base from the here. That's the base. 180 n plus 90. Now, still the Pythagorean theorem. We find the x to y for the end. So, x, y distance for the end. So top is the flag. So the xy for the end, the square, xy square equal to, that's the 180 n plus 90 square. That's the bottom from x. If this one is the z, this point, that's the xz square, plus yz square. Yz is the 155 square. So xy, so nth the distance, that's the square root of the 180 n plus 90 square plus 165. Now we want the end distance. That's the x, y, a to be at least 20, the distance of the at least, that means the greater or equal to be the 20 flights distance. That's the x, y, f. X, y, a, that's the square root. 180 n plus 90 square plus 165 square greater or equal to 20 times the flight distance. Flight distance is the xyf. That's the square root 30825. Square both sides, 180 n plus 90 square plus 165 square greater or equal to 20 square. That's the 400 times 30825. That's equal to 1, 2, 3, 3, 0, 0, 0, 0. Now the 180 n plus 90 square greater or equal to 1, 2, 3, 0, 2, 7, 7, 5. So take the square root. 180 n plus 90 greater or equal to 3507. I keep the 4 digits, the decimal places, 5312. So 180 n 3, 4, 1, 7.5312, and the n greater or equal to 18.986. N greater or equal to 18.986. They ask smallest possible value of the n and also The n is the positive integer. That means the n is the 19. The answer of number 25 is 19.